Hi friends, welcome to our channel. Let's have a look at problem 3443, maximum Manhattan distance after key changes. This is today's daily challenge problem, and in this video, we are going to analyze how to do this problem and digest it. We are not going to read through the problem statement, but here we want to mention two things. First is the Manhattan distance. So this is also the so-called L1 norm for a vector. Then the second one is the size of the problem. So here the length of this character string s can be bounded above by 10 to the power 5. And this is a decent large number. And the last two bullet points are some consistency instructions. So with that said, we are ready to analyze the problem. So first, we need to make the following observation. So in order to make the Manhattan distance larger, so we actually should have the intuition. We just need to leave to the origin as far as possible, right? So in order to achieve this, so we need to try to move towards one direction, horizontally and vertically, right? So here are the splits of this observation. So horizontally means you move to east or west. Then the more you towards a single direction, the larger it contributes to the L1 distance or Manhattan distance. The reason is that if you reverse, so the final distance along the horizontal one would be the larger direction minus the smaller direction, right? So this is actually the difference of the frequencies of east and west in the sense of absolute value. By symmetry, this is the same vertically. So in our code or execution, so we can count horizontal moves, the east and the west. So we get the smaller one and larger one. The same for vertical ones. And then we analyze the horizontal and vertical contributions to the L1 distance by flipping. The flipping constraint is, given by key, right? So then we want to also mention that the flipping can be first done vertically, then horizontally, or you reverse. The final result will not be affected due to symmetry. So now let's monitor this process. First, let me initialize and answer. So this will be the final state of this variable is what we want to return. In other words, answer is going to monitor in the moving process the largest possible Manhattan distance. So here let me have a frequency count. So it's collections counter, right? This is a dictionary with default value 0, right? And then we are going to iterate for character in S. Then we get, let's first increment this frequency by 1. And then we look at the horizontally the larger counts and the smaller count, same for vertically. Let's do vertical little m and vertical capital M. So it will be mean frequency. So here let's count north and frequency, let's count south. This is the mean. So we can do the same, but for max, right? So similarly, we can count horizontally. So the horizontal M and the horizontal capital M, it will be mean frequency. So east and the frequency west. So same thing, we can got the max. So now during the movement at this step, so let's see what's the largest possible Manhattan distance. So we are going to consider the relation of little Vm and HAM. So this is the potentials we want to change. So if this is less than or equal to k, it means that we have a lot of freedom. We can change all those directions corresponding to little VM. For example, the little VM corresponding to north, you change all the north to south, right? So for example, here you can change all the east to west, right? So in this case, so let me make a remark. So we have a lot of freedom. We can change or we can flip such that both horizontally and vertically all the letters moves towards that direction, right? So in this case, we just need to count all the characters so far, right? So the candidate, so mathematical candidate, will be sum of frequency values, right? This is the one. Another case is that, so we cannot change all of those, right? But what we have is v little m is less than or equal to k. So in this case, we can actually change all vertical, let's see, vertical small direction letters or characters to larger direction characters. Still, we can change part of the horizontal ones. How many we have? So we can use VM among the key. We can use VM to change all the vertical ones, and then there are k minus VM. So this for horizontal changes, right? So now let's look at the counts. So vertically, because you changed OR, so the candidate will be vertical little m plus vertical capital M, because you can make the vertical direction one direction. And then, so you can change part of those. And then you have HM, so this is the vertical larger direction. And then for the smaller direction, you can change this, right? So this number of smaller characters, smaller direction character can be changed to the same as the larger one. So this is the increase. And then you need to, so this is the number of total smaller direction characters horizontally. And then this amount is changed, right? So actually, if you do some algebra, it would be 2 times this k times v minus h, right? But let's keep this format for the ease of understanding. And then another case is that we can Vm will be greater than k. We can only change part of the vertical smaller direction character to larger ones, larger direction characters. So we can only, because Vm, in this case, Vm is greater than k, we can only change part of the vertical smaller, can change k, right? Can change k among Vm. So in this case, the candidate, so vertically, so we have capital Vm, and then we can change k among this, so we can add this k, and then we are going to minus, because it's smaller direction, Vm minus k, right? So this is the contribution of vertical direction. In the horizontal direction, it would be h capital M minus h little m. So let me add some parentheses. So this is the horizontal contribution. This will be vertical contribution. So similarly here, so this will be vertical, and this will be horizontal, right? So we get the candidate for each cases. So now we update the answer, be max of answer and candidate. Then finally, after this for loop, so we're going to return the final stage of this answer. So this will be the full code for this problem. So now let's do a test. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes all the cases. So here you can do some analysis about the time complexity. For example, this is the major for loop. Let's see, this will be proportional to the length of this S. For example, O of n. Let's see each of those, how many time complexity it comes. So here we have this one is O1 operation, and also we get this one. This is also O1. This is also O1, and this computation is also O1. So overall, it's O of n. So with that said, I guess that's it for the current problem. I guess it's very important to establish the intuition. In other words, this observation, and then what remained is just the counting. But another thing to be noticed is that the requirement is that find the maximum halving distance from the origin that can be achieved at any time. That's why in each step of this for loop, we are going to do this answer max and also these parts. So with that said, I guess that's basically about it for the problem. Thank you for watching.